forget this recording business. I'm not used to because bored. We don't remember this. Initially, we said that how to measure strain, so we will skip all these things because these experiments you will be doing. Now we said that in one dimensional, let us say A is at a distance x from the fixed end, B is at a distance of x plus delta x. Now, if you apply some load, A gets deformed by U and naturally B gets deformed by U of x plus delta x because U is a single valued function. I can substitute x plus delta x and I can evaluate what is U at this point, deformation at this point, B dash, let us say. This is A dash and A has gone to A dash. That means it has slightly moved away from the fixed end. B will move slightly more away from fixed end because it is much away from here. We used Taylor series and we took only approximation only up to first order approximation we made because we said that delta x, because according to our Taylor series delta x is small, that means it is small means delta x square is much smaller than 1. So the higher order terms, the delta x square, delta x cube and other things of negligible value, so we can neglect. So we can stop our approximation here. Now we have strain, we have found this is the total length A dash B dash minus the original length divided by delta x will give you as delta x tends to 0, but that usually nobody writes because it is understood, because we are talking about strain at a point actually. Okay, so see, this is single valued function of x. Only x is the variable. You can always write this as, instead of dou u by dou x, we can write it as du by dx. But most of the times we will have not one variable, we will have more than one variable. You will end up with partial derivative. The strain what you have studied and in previous classes is deformed length minus original length divided by the original length. Okay, since it was strain was along x direction, we will put in a subscript epsilon xx, that is along the x axis, the strain. We said 2D deformation we can do. In this case, we will have only U and V deformation. W deformation is 0. They are all functions of x, y. That means if the point is lying in xy plane, after deformation they will remain in xy plane only. That means if you consider a rectangular element, you apply in-plane load, they will remain in the same plane, but it will also undergo some deformation. Because let us say you also not allow deformation in the z direction. You have some constraint in the z direction. Let us say we held it together like by in the case of dam, abutments, or in the case of tunnels, both ends are fixed. So naturally you cannot move in the z direction, so W can be taken as 0. So we can do all these things. We will skip. We will. What do you get? We will see that what are the deformations here given. Deformation here is given. The deformation, the original length which was xy, A has moved by a distance u, and B, as you know, it has deformed by u plus du by dx into dx. But also B dash that has moved Vertically also, because it is a function of two variable, it has also moved by dv by dx into delta x. Similarly, we can write for all other things. Based on this, I can write what is strain. Let us say if linear strains epsilon xx and epsilon yy is nothing but a dash b dash. You take a projection on x-axis. So a dash b dash minus ab divided by ab. This is du by dx divided by into delta x divided by delta x. So it will become du by dx or dou u by dx, because now u is a function of x and y. You can represent it as partial derivative. Epsilon y, we can write it like that. Gamma xy is the if you consider two orthogonal direction, what is the change in the angle from the 90-degree? That is known as the shear strain. Here you have found out shear strain as dou u by dou y plus dou u by dou x actually. Okay. So far it is fine. So we can also solve problems. It doesn't matter. Now you can also make strain in 3-dimension strain at P. That means we are always, remember, we are denoting here all other things. What we have denoted is strain at A actually. Other things are immaterial. See, we are only considering the strain at A actually. That means delta x and delta y, they shrink to almost 0. Okay. So we don't put 0. If you put 0, then 0 by 0 will come, then we will get into trouble. So you will have to go to IL hospitals rules, or you will have to make some other thing. Okay, anyhow, these are all very minor things. Now we want to find out what is strain at P. We will get epsilon xx is equal to dou u by dou x, and this is dou v by dou y, and this is dou w by dou z, gamma x y, gamma y x, all those things we can write it because they are symmetrical. Because they are symmetrical, because shear stresses are symmetrical. So you will have dou u by dou y plus dou v by dou x. And similarly, I can write all the three shears, other two shear strains also. It is very simple. So I will not go into detail actually. Now, before I do strain transformation, I wanted to tell you something very curious thing. You see, let us say you all know that stress is a tensor. Huh? We will talk about strain tensor. Here, the normal strain and the shear strain, the normal strain and shear strain, like you there in the normal stresses and the shear stresses put together, you can express them in 3x3 matrix. That is known as a strain tensor. Because it is called as a tensor, because it obeys certain laws when they undergo transformation. Okay. Now, similarly, the normal strain and the shear strain are constitutes a strain tensor, but it is not that straightforward. normal strain it is fine, I can take the same thing, but shear strain I will have to make slight changes if they have to obey the tensor transformation equal. What is that tensor transformation property? You don't ask me because you will be studying in your if there are some dual degree students, I think you will be studying in your MTech actually, but it is quite advanced, so we will not go into detail. So only I will tell you, you take it for granted. If you shear strain has to be a tensor, then we have to make slight modification. What is that modification? We will see that. Let's say this is x and y axis. Okay. Now let us say I have put delta x, delta y, this is delta x, and now let us put this is gamma xy by 2, this is gamma xy by 2. Or you can express them, let us say, from the horizontal axis. Put in a different color so that it will be more clear. That means this is gamma xy by 2 and the other one is, but you see this gamma xy by 2, if you represent like this from the horizontal axis and the vertical axis, then this can be obtained by rigid body motion. So this gamma xy by 2 will not be a legitimate tensor quantity. So that's why what we will do is, one more I want insert. See, I can rotate as a rigid body, then I can get this gamma xy. But instead of that, actual tensor, tensor shear strain, where is it? Yeah. Okay. The x y axis, our element of small delta x length, delta y width, whatever. Then this will be like this. So instead of that, what I will do is, So this one gamma xy by 2 and this one gamma xy by 2. This is actually the tensorial component, tensorial shear strain. This actually is represented by epsilon xy. This is epsilon x. So this is what is the tensor shear strain. So later on you will have new slide. Okay. Our tensor shear strain is what? Like epsilon xx, epsilon xy, epsilon xz. Then this is epsilon yx, epsilon yy, epsilon yz, and epsilon zx, epsilon zy, and epsilon z. This is tensor tensor strain. Like you had a stress as a tensor quantity, that is it had sigma xx, sigma xy, sigma xz, sigma yx, then sigma yy, sigma yz, and all those things. Similarly, we have now tensor. Here you should remember that these are all equal. Not responding. Okay. So these are all equal, and zx and xz, they are equal. Zy, yz, they are equal. Okay. So this is how we know that tensorial quantity epsilon x y is gamma xy is, but gamma xy why we introduced, we call this as engineering shear strain, engineering shear strain, because it is very attractive, physically it is what the 290 degree makes, what is the less than that 90 degree, that is very attractive definition, isn't it? So that's why we introduce engineering shear strain. Then we tell that this is not the correct one, we have to use tensor quantity. If it gamma xy doesn't come in the tensorial shear strain, so naturally what is actually tensor quantity is epsilon xy by 2 epsilon xy. Okay, so just this is now this tensor strain is known as the pure strain quantities or the irrotational shear, because if by rotation you cannot obtain from one from the other. Okay. Now what we will do is we will find out, given the strain in x, y, z coordinate, how to obtain strain in, let's say, Okay, I hope it is there. Strain transformation in 2D we will see, then we will know what strain transformation in 3D. By extending that by 3D we will discuss later. You all know stress transformation in 2D. That is, if the stresses are given in xy coordinate, how to calculate stresses in x prime y prime coordinate, you all know. Actually, those were discussed in your previous, I think, by Professor Hussain. Also it has been discussed in your first year, I believe. I don't know whether now the first year they have removed the stress transformation. Now for strain transformation, there are two approaches. One is the geometric approach, another one is the analytical approach. First we will consider geometric approach because it is very easy to understand. Okay. Now you consider a small element, infinite small element of sides delta x and delta y. Just left hand corner I have denoted by O, and this is A, diagonally opposite point I am denoting by A. Now let us say these things, let it undergo strain along x-axis, y-axis, and in shear strain respectively. Okay, only first let us say it undergoes strain in x direction. Strain in x direction means epsilon x or epsilon xx. So if A moves to A dash, then this strain at any point is epsilon x. So naturally, if this length is delta x, so the total deformation is epsilon x into dx. Is that okay? Now we will plot that deformed configuration. Now this is O and this is A dash. Now I apply stresses in the y direction, so I will have strain in the y direction. Only strain in the y direction. So I will have epsilon y. Epsilon y at any point. Let us say we will have uniform strain for our easy understanding. So the total deformation A dash to A double dash will be equal to epsilon y into dy. Now again you will have uh, uh, shear strain, then A double dash will go to A triple dash. Actually shear strain, as we have just discussed, we have to denote by gamma xy by 2, gamma xy by 2. For my simplification, for the geometric simplification, I have moved this gamma xy by 2 here. I am writing it as gamma xy into delta y. This length A double dash to A triple dash, this is gamma xy into delta y. Is that okay? Now let us say all these things, let us say we have got a coordinate x, coordinate y, we rotate by theta. We rotate by theta, we get x prime, y prime. So we know strains in xy coordinate, that is epsilon x, epsilon y and gamma xy. Let us try to find out strain in x prime, y prime coordinate. Okay. Xy, now it is required to find strain in x prime y prime axis. Let the angle between axis is theta, that is shown here, so there is no question. Now let us say initially the rectangle undergoes stretching along x-axis followed by along stretching along y-axis. Finally it undergoes shear deformation. What I will do? I will have the same xy coordinate original. Now this is y dash, this is x dash, this A point will have total length delta x, delta y. Because A, if you see A initially it is at delta x away from, if it is 0, 0, then this is delta x, delta y. Okay, from the origin. Up to here it is. Now what happens? It undergoes stretching in x-axis epsilon xx into delta x. Then this A dash will go to A double dash. You see A dash will go to A double dash. That length is how much? A dash, A double dash. Then it goes to A double dash to A triple dash because of shear strain. Is that okay?
Yes, sir.
See, somebody has to answer. Otherwise, I get a doubt whether I am telling it properly or not, or whether you are following or not, because this is what I am teaching for so many years. So, also in the class, some reply will be, because I am getting a doubt whether you all have put the computer on and you are wandering somewhere else. So A double dash to A triple dash. All of you are okay?
Yes.
Yes, sir.
Yes,
Else,
sir. Yes, sir.
Yes, sir.
elsewise. Okay, okay, that is great. Now, let us say A triple dash, we will join with the origin. There will be a small angle alpha. We'll assume this alpha to be small because our deformations are infinitely small. In the sense, they are very small. Now, so alpha, we will talk about alpha also. I will just come. Alpha is small. That means if you have got a tan alpha, I can approximate by alpha itself because alpha is very small. Why a very small? Because my A dash, A dash, A double dash, A double dash, A triple dash are all very small because my delta X and delta Y are very small actually. Is that okay? So naturally that epsilon x into delta x, they are all small. So the resulting angle, the A triple dash, I have joined with this one. So naturally then let us say, now I want to find out strain, let us say along x prime axis, x prime, y prime axis with respect to. Let us say first I find out epsilon x prime. How do I find out? I project this point, and this point is also you can project from here to here. Whatever is the length, that length is your epsilon x into delta x prime. Because this is totally you have epsilon x delta x prime, epsilon x prime into delta x prime. Okay, now in xy prime axis it is elongation of OA diagonal. Actually, that alpha, if you neglect, what exactly happening is finally you see A gets stretched and A gets okay. We will try to draw that. A initially we said that no, let's put this on. A will go to very small, but I am making it big. A dash and A dash will go to A double dash, and then this will go to A triple dash. Now if you join this line, this angle we are calling alpha, which we can presume to be very small because my A dash, A dash, A double dash, A triple dash are all small. Okay, now what we will tell is, okay, I have done one by one. Yeah, together it may be confusing. You see, initially A has gone to A dash, you project it to X prime axis. So this will be, then immediately I will get similarly when I do this, I project it to A prime axis, A double dash, I project it to X prime axis. So this is what I will get. So this I know that epsilon y delta y sine theta. Okay. So similarly I can project it to X prime axis, I can find out. Now since, sorry, I have written wrongly, I think. Everything when you are projecting it to X prime, this is what is epsilon X prime actually. This is a component of epsilon X prime. So epsilon X, because you are talking about along X prime axis, epsilon X prime delta X. This is the deformation. You see, total length. See, I can't compare the strain like stresses. So naturally the deformation I am comparing, epsilon X prime into delta X prime will be equal to A cos theta, A double dash, this one sin theta, A double dash, A triple dash cos theta. So you can easily find out what are all those things. Epsilon x delta x, because A dash is nothing but A epsilon x delta x cos theta epsilon y delta y sin theta gamma xy delta y cos theta. Then this is delta x by delta x prime. So you know that delta x by delta x prime is cos theta, delta y by delta y double dash, y prime is sin theta. So I will get this as epsilon x cos square theta, epsilon y sin square theta, gamma xy sin theta cos theta. So otherwise this is in the stress transformation you have written. Similarly, instead of sigma x plus sigma y by 2, I have written here as epsilon x plus epsilon y by 2, epsilon x minus epsilon y by 2 cos 2 theta, gamma xy by 2 sine 2 theta. Now this may not be very what do you call nice. So what I will do is, if you want, um, we will introduce one more. What happened? See, uh, now let us say we have got some small element. Huh? This is delta x, this is delta. That is what we started. Now let us say I have got x prime, that is angle theta. I hope this is also theta 1. It doesn't look like theta, please assume that it is also at angle theta. Okay, now what will happen? This chap, let's see. We called it as, let us say, A, B, C, D. Okay, C will go to C dash, B will go to B dash. Now what you want? We know this, but we want this. Isn't it? So this angle is also, sorry, where did it go? I don't know. It doesn't look like 90 degree. Let us make it 90. I'm sorry, I don't know why it is happening. Is there any problem? Okay, maybe. You give me 1 minute. I don't know what is happening. Let us say we call this E, this E dash, this we call it E dash. Okay, I am just, you all know what is this one. This is epsilon x delta. Okay. Now epsilon x prime, that means along x axis. This is nothing but e, e double dash divided by because it has gone to this divided by its original length was AE, so we have written that one. This E double dash, we can write it as E dash cos theta. This we can write it as AB by cos theta. This is what will happen. E dash is epsilon x delta x divided by AB is delta x, so it will become epsilon x. This cos square will go up. Okay, I believe that's what we have done for epsilon x. Epsilon x cos square theta. Similarly, you can do for y. If you want, I can do for y, let us say. It is just a separately one after another we will do. When yes. Okay, now this will be A, B, C, D. So I will have C dash. Now let me take axis anywhere I like. I call this as x prime. My extension along y direction is, let us say, y direction is extension is E dash, then I will write draw perpendicular E double dash. Now again you will have to find out, sorry, is it pressing something? So similarly you can do for this, similarly one can do for shear strain. So there is not much problem. So I will not complete this angle, you know, theta, so you can find out what is E dash extension divided by OE. You can find out OE, then the original length, then you can do the same procedure. So that is what I have done. And now shear transformation is slightly different. In the sense, you will have to find out the change in the angle between, you see, initially it was between x and y. Now, with respect to new coordinate axis, x prime, y prime, what was the change in the axis? The angle. This angle is alpha, this side angle is beta. Let us say we need alpha plus beta. Okay. So this is all the deformation we'll have, A dash, A dash to A double dash, and A double dash to A triple dash. Now if you write all, have I written? Okay. Alpha is equal to, because tan alpha is very small, so I have made tan alpha as an approximation to alpha. That will be along this the axis, that dotted axis. This axis, what is the projection? I have found out as minus a dash sine theta, all those things, minus a double dash, a triple dash sine theta divided by delta x. You all know this, this delta x by prime is cos theta, other one delta y by delta x prime is sine theta. So this will become slightly this way. So beta will become, so alpha plus beta will become epsilon x minus epsilon y sine 2 theta, gamma x y cos 2 theta. Okay. So the rest of the thing, it is slightly different from the stress transformation. What is different from the stress transformation? The equations are not exactly similar. Epsilon x is same as sigma x, but your beta, that is alpha plus beta shear transformation equation, is slightly different. If you can recall, I will be very happy. Otherwise, we will discuss this tomorrow. I come prepared, so that we will say what was the stress transformation equation and what was exactly the strain transformation equation. Is that okay? Is it clear or not clear?
Yes, sir.
We will
Yes,
all,
sir.
we will also
Yes.
do, I think, analytical approach also I will do. So you will compare which, because this is a physical approach, a geometric approach. You know what are the deformation, where you have to take the projections. You know, so it is very easy to calculate. That's what we have done since high school days. You take a projection, then all those things. So this is similar to that one. Okay. Uh, Let us see. Attendance we will take. How many participants? Download attendance list. Okay. Then stop recording. Stop. Oh my God.